Hi, welcome to my channel. In this session, we are going to discuss the present value and future value of annuities. This is under the time value of money series. In the previous session, we have discussed present value and future value of single cash flows, but today we are discussing the present value and future value for annuities. So let's understand what is an annuity and what is the difference between annuity and a single cash flow. If you receive a cash flow only once, either at the beginning of the period or end of the period, it is a single cash flow. The cash flow is received only once. But what if you receive the same amount of cash for a long period of time, annually or quarterly or monthly? If you keep on receiving or keep on paying the same amount of money at certain intervals, it is an example of annuity. Annuity is generally an annual payment, but annuity examples can include monthly payments, monthly receipts, etc. So annuity represents a series of equal payments occurring over a specified number of equidistant periods. Equidistant means monthly, annually, or quarterly. For example, pension received each month, insurance payment being paid at the beginning of each period, school fees, telephone bills, electricity bills paid at the end of the period. These are examples of annuity. Now, there are two annuities, two types of annuities, annuity ordinary and annuity due. If the annuity is paid or received at the end of the period, at the end of the year, end of the month, end of the quarter, end of the 6-month period, it is an ordinary annuity. So annuity, the payments are received which occur at the end of each period, is ordinary annuity. If the same payment or receipts occur at the beginning of each period, it is known as annuity due. Ordinary annuity is generally annuity, general annuity, which when somebody says annuity, it is an ordinary annuity. Annuity due has to be specified. So if somebody says annuity is being paid at the beginning of each period, then it is annuity due, or it is called annuity due by the source. Examples: student loan payments paid at the end of each month, car loan payments end of each month, insurance payments beginning of each month, mortgage payments end of each month, retirement savings end of each month. So these are examples of annuities. Now let's go to present value of annuity. So we are concerned with annuity due, we are concerned with present value of annuity ordinary. So we will discuss ordinary annuities in this session. Annuity due will be discussed in the next session. The example: find the present value of the annuity if the payment is made $500 annually for 7 years with interest rate of 14%. So you can see here the future value of the annuity can be calculated as annuity multiplied by FVIFA for I rate of interest for n number of years. Present value of the ordinary annuity would be annuity into PVIFA for R rate of interest for n number of years. So if you are paying 500 each year, then annuity amount is, ordinary annuity is 500, n is 7, rate is 14%. So PVIFA 7 years for 14% is this. So we are using this formula. So you will get this amount. You can see here the present value of annuity table. Like the previous tables, present value factor table, PVF and CVF tables, this is for different rate of interest for 1 to 15 years. So you can calculate like this. There will also be a table for future value of annuity. Let's calculate the present value of annuity. The future value is annuity multiplied by this, n for I rate of interest. How much required money should be invested each year so that you accumulate 3 lakh at the end of 10 years if interest is compounded annually? So rate of interest is 10%, years is 10, you need a future value of 3 lakh. So what should be your annuity amount? That is present value of annuity for should each year you pay so that you are able to accumulate 3 lakh at the end of 10 years compounded 10% per annum. So 3 lakh future value is annuity multiplied by present value of factors 10% for 10 years. That's 15.93742448. You will get it from the table. So 3 lakh divided by this is annuity. So this means each year you have to deposit $18,823.62 for 10 years to get 3 lakh future value. So each year you need to deposit this amount to be able to get a future value of 3 lakh at the end of 10 years if interest rate compounded is 10%. Another example, an investor deposits a sum of $100,000 into a bank account. Bank is paying 10% interest. Periods are 15, so 15 years. So this means your present value is 1 lakh. No, it says how much amount of annuity can be withdrawn. So now you are depositing 1 lakh dollars or $100,000. You need to withdraw in 15 years an equal amount given 10% rate of return. So 1 lakh, which is the present value, is equal to annuity amount multiplied by present value of annuity factor of 10% for 15 years. So this means you get annuity of 7.606. This is the PVIFA. So divided annuity amount, annuity is replacing the items on both left hand side and right hand side. 1 lakh divided by 7.606, you would be able to withdraw $13,148 each year for next 15 years, given you have deposited 1 lakh $100,000 into the bank account at a rate of interest of 10% per annum. There is a loan amortization example. You have given that Julie is borrowing 10,000 at a compound interest of 12%. If payment is to be made over 5 years, so n is 5, rate of interest is 12, present value is 10, so annuity is equal to 10,000 divided by the PVIF amount for 12% for 5 years. So annuity is 10,000 divided by this 2774. This means if you have taken a loan of $10,000 at 12% per annum and you intend to repay it in 5 years, you have to pay 2,774 per annum for the next 5 years. So this means you keep paying 2774 each year. Fine. So the present value of this stream of payment for 12% for 5 years is 10,000. That is what written here. Annuity multiplied by present value factor of annuity is 10,000. So this you can use for a general loan, a home loan, or a mortgage loan. So if you treat this 10,000 as mortgage, then you are paying a mortgage amount of 2774, which includes the interest. Amortization of mortgage, we will undertake in a general session for that. Amortization of mortgage loans, how interest is calculated, how the mortgage amount is calculated, how the payment is calculated, how much interest you are paying each month, and how much principal you are repaying each month. Next, we are coming to future value of the annuity. If you are depositing certain amounts each year, what will be the future value given a rate of interest, given the n number of periods? The table is given 1 to 12%, but we can have a table of 1 to 25% for 50 years. I can send you the tables if you request for that. You can also download it from internet sites. The name of the site, details of the site was given in the previous video, so you can refer to that as well. For example, suppose say a firm deposits $5,000 at end of each year. Remember, this is an ordinary annuity, end of each year for 4 years. So how much money will accumulate in the account at the end of 4th year, given 6% interest rate? So future value is annuity multiplied by FVIF or CVAF for R percentage for n number of years, that is 6% for 4 years, 4.3746. So you will get an accumulated amount of 21,873 at the end of 4 years. You can see the CVF amount, it is compounding. The values will get increasing and increasing. Power of compounding. Another example, a person is required to pay 4 equal annual payments of 5,000 each, which pays 8% per year. So future value of annuity is 5,000 multiplied by CVAF 8% for 4 years. So this amount is what is accumulated in the account at the end of 4 years. A sinking fund, suppose say a machine is costing $98,000, life is 12 years, and scrap value is 3,000, which means we need to invest 98,000 minus 3,000, 95,000, which is the effective cost of the machine. So that's the future value. We need to pay an annuity amount into the bank. The bank pays 5% per annum, but we need the sum after 12 years. So n is 12. So annuity multiplied by CVAF of 5% for 12 years, which comes to 15.917. So by reversing the amounts, annuity is 95 by 15.917, That's this much. This means from the profit, the company needs to take out 5968 each year and deposit that into a sinking fund or a general fund which pays 5% per annum for the next 12 years, so that you are able to generate $95,000. So with that amount, you can be able to borrow the new machine. So I've come to the conclusion of this session. I hope you understood. In case you have some doubts, typically these are very difficult topics. So it's actually hard to grasp all the things in at one go. In case you have any doubts, you can send me a mail, you can WhatsApp me. I can send you more uh, examples, more tables, so you can practice, and whatever you can't understand, you can ask me in the mail. Please subscribe to the channel. Also like the video. Thank you so much. Till the next time. Next time we will discuss annuity due. Till that time, bye bye. Thank you so much.